guess we'll get started. I'm going to bypass questions today because really I think, well, first of all, let me explain. I had a few difficulties sending you that stuff yesterday. I went to my WLC, which lets you do a email to everybody in the class, and I made my attachment, and I sent one to myself too, just to make sure, and then I got the one from myself, and it said attachment removed. I think it didn't like the size of the attachment, so that was why you got an empty one from me first. Then, oh my goodness, I tried a number of different things. I finally wound up putting the missing problems in a PowerPoint file and sending them to you. Did you get a PowerPoint file from me? Were you able to read it? You didn't get one.
Well, I got it, but I wasn't able to read it.
You weren't able to, okay. So maybe I should just make copies and hand them out to you guys. I guess that's what I'll do. Okay. The rest of you were able to make use of those PowerPoint things? No? No PowerPoint? Okay. I'll print them out. Then they'll be universally. I don't know, I should have just gone to the copy machine. Okay. Actually, there was another thing I had problems with too, but you don't need to hear about that. So on we go. Lesson 3.5. Business and econ applications. So a bunch of this is going to be review, but you will notice some new stuff here. Above the line, I believe that's all old stuff. You guys have all seen that, that R equals XP, small p stands for demand, and you have to multiply it by X to get revenue. That's a review. All of you know that you take revenue and subtract costs to get profit. The one we brought up last time, which we did have earlier in the year, is this average cost thing, which the book uses like a bar over the C for. Average cost is simply the cost divided by X. And then there's this one new thing in business that comes up today. That funny looking elongated N there is the Greek letter eta. Anyway, it's called the elasticity of demand. And it's a fairly complicated thing. It's P over X, P divided by X, divided by dP dx. That's the first time, I'm quite confident that's the first time we've talked about that. That's going to come up. It's not a huge thing, but it does come up in one part of the assignment. Well, the rest of the assignment is knowing how to take, there's nothing new. Knowing how to take a derivative, knowing that derivatives are instantaneous rate of change. So, I'm diving into some problems right away, right from the 3.5 assignment. And what I've done is spread them out. I kind of picked one from each section. So the first one I'm going to do is in the first section. It's number 2. And before I show you what I've got underneath that, I'd like you to kind of guide me a little bit. Look at the directions above number 2. This is page 217. It says capital R equals 48x squared minus 0.02x cubed. Find the number of units, x, that produces a maximum revenue R. So we've got an R equation. How can we find maximum revenue? So this is a review question now. If that's revenue, how do we find maximum revenue? Start by finding the first derivative of the revenue, and then okay, that's just the beginning. What do I have to do with that derivative? Set it equal to 0. Why? Because at 0, when the slope is 0, we know we'll reach at a high or a low point. Yeah. And then solve for x. And that's basically what I did here. So I first did the derivative. I could have called it r prime. Here I just said dr dx. Easy derivative, just the power rule. Set the derivative equal to 0. Do a little bit of algebra. 1,600 units will maximize our revenue. So if I'm the boss, I'm going to do everything in my power so we can start making 1,600 units. Because then we have the best revenue. Of course, this is a little bit on the blind side because I probably need to examine what does that number of units do to my cost, right? Actually, the bottom line is really dt, the rate of change of the profit. But still, this is the kind of thing people who are managers or bosses are trying to do. Okay, so that one's pretty easy, right? Straightforward. I don't think there's any surprises there at all. When you go to the second part, the directions say, find the number of units X that produces the minimum average cost per unit, C bar. And they give you a C equation. And I've picked out number 6 from this section. So, now let's see. This is a little fresher. I know we couldn't remember the average cost only faintly. Do you remember yesterday? How do you find, if you're given a cost equation, how do you find the average cost? Divide by X. So you just that's how you begin. Now that you've got an average cost equation, how could you minimize the average cost? So step 1, let's follow Jesse's advice and let's divide by X. Okay, that gives you, don't forget to divide every term by X. And so that last term becomes 250 over X. So now I'll ask it again. How do I minimize this average cost? This is the same old story. Find the first derivative, set it equal to 0, and solve. So that's why you see I called it dc bar dx, because I'm finding the derivative of this average c with respect to x. Maybe we shouldn't go so quickly here. Does everybody see how I got this? I mean, I know all of you see this. How did I get this? How do you differentiate this? There's a couple ways to approach it. Give me one way to approach it. Anybody? Ben? Yeah, so it's, let me start with that one. And that is denominator times derivative of numerator. Well, derivative of numerator is 0, so that's gone. Minus numerator times derivative of denominator. Well, that's 250 times 1, 250, over denominator squared. Or, what's another approach to differentiating that? Instead of using the quotient rule, you could just think of this as 250 x to the minus 1. And then you could go ahead and just do the power rule. And you're going to wind up with an x to the minus 2, which means this. Okay. Then what do? You set the derivative equal to 0, solve. I wound up finding out that the minimal average cost occurs when I have 50 units. Yes?
What is
DC bar? Well, do you get what C bar is, first of all?
Yeah.
Okay, so we got the average cost. What I'm saying is I want to find the derivative of this C bar. So this is just saying, I could have written this C bar, fine. Same thing. But I want to remind you that this notation sometimes has advantages to it. So this is saying, find the derivative of C bar with respect to X. Is that problem? Again, there's probably nothing Very surprising there. Really, what's the only new thing, kind of new, is that you got to remember how to find average cost. Divide cost by x. Okay. Next section in the book says, in numbers 9 to 12, find the price per unit, P, that produces the maximum profit, P. Just take a glance at what they give you there. Does that look at all familiar? Haven't we done problems like that in the past? You look at that and go, oh, wait a minute, how do I find profit? I got to subtract cost from revenue. Okay, but I don't have revenue. That's true. So what do I do? Yeah, take demand and multiply it by x, and then you got revenue, and then you can go ahead and, okay, so here we go. So like was just said, we have to take our, oh, by the way, I'm doing number 10. So the demand was 60 over the square root of x. I had to do like we just said, you got to multiply that by x. When I multiplied it by x, I got this, what I'm circling here. But I thought that might not be the best form, so I also then multiplied it top and bottom by the square root of x so I could rationalize the denominator. And then what happens? The x's cancel, and you just get 60 times the square root of x. Okay, so there's my revenue, 60 times the square root of x. So now I got to do this line. I got to find the profit. So I take the revenue, which is this guy right here, and from it I subtract the cost. Do you see why then I have minus signs in both locations? Minus 0.5x, minus 600. Okay, and then finally, I want to maximize profit, so now we take the derivative. That's what I'm doing on this line. Okay, let's see if we did that right. Well, the first term is what? The product rule, the first times the derivative of the second, plus the second times the derivative of the first. Well, the derivative of 60 is nothing, so I have no second part to that product rule. Simplified, what is that? 30 over the square root of x minus 0.5. And now to finish it off, set it equal to 0 and solve. You're going to need some, I got to extend this, otherwise you can't see what I did. And so I found out 3,600 units maximizes my profit. So now, not always the easiest thing. Can I crank up the machines high enough in order to produce this amount? Do I have enough stock? You can't just crank up the production unless you have enough stock to go ahead and do that. And so all kinds of things have to follow. And here's another thing about that. If you have more stock, what does that mean? It means you got to pay out more bucks. It doesn't mean you're going to maximize your profit, but you're also going to have to outlay more. In other words, you got to have some cash on hand so you can buy enough stock so that you can actually do this. It gets to be kind of complicated. It's not like just, let's just produce 3,600. Might have to hire more workers. All kinds of things might happen. I'm not quite sure why this big bar is here. I think originally I was going to do some more calculating here and I didn't need to. So, any questions on that one? Darnell?
So, to turn a profit equation into revenue and multiply that to...
No, that's not profit. That small p, this is confusing. Capital P is profit. That little small p guy stands for demand.
Oh, okay.
To turn demand into revenue, you do have to multiply by x. Profit is, I wish they were both the same letter. Capital P, that's when you do the revenue minus the cost. All right. So on to the next section. This part says average cost. In exercise 13 and 14, use the cost function to find the production level for which the average cost is a minimum. For this production level, show that the marginal cost and the average cost are equal. Oh boy, I got to remember what's, oh yeah, what's marginal cost? Do you remember that one from previous work this year? Just the first derivative of the cost. The derivative of the cost is called the marginal cost. So that last thing they said is show that the marginal cost and the average cost are equal. So in other words, show that C prime of x is equal to C bar. Interesting. Okay. So here we go, number 14. We've been told that the cost function is x cubed minus 6x squared plus 13x. So step one. Well, I found C bar right away, but I'm sorry, I found C prime right away. But we need C bar too, don't we? And to find C bar, you have to divide by x. Okay. Then we're supposed to maximize the average cost. So I got to take the derivative of C bar. And I wind up with 3. X equals 3 will maximize C bar. I'm sorry, minimize C bar. Then, let me tell you what I'm doing up on the top right. I found out 3 is the best. All right, what's the average cost at 3? What's C bar at 3? Just come into this equation, plug in 3, and you get what? 9 minus 18, which is negative 9, and negative 9 plus 13 is 4. And then I found C prime at 3. Let's check, make sure I did that right. 9 times 3 is 27. 27 minus 36 is negative 9, and negative 9 plus 13 is 4. And do you see how I've shown that C bar at that maximum ideal number of 3 is exactly the same as C prime at 3? Problem complete. So part A, just let me make sure you get, there's a lot of stuff to do here. It says, show that the marginal, find the production level for which the average cost is a minimum. Okay, that was this part. X equals 3. Then, show that the marginal cost and the average cost are equal. That I did up here. Let's see, am I supposed to do one more thing? Use a graphing utility to graph the average cost function and verify your results. Well, okay. Let me just quick do that. So make sure I can see what's going on here. The average is x squared minus 6x plus 13. And then I'm going to also plot C prime. And that is 3x squared minus 12x plus 13. Something is not correct. What I was going to show you is that at 3, they both cross at the point 3, 4, and they don't. This one goes to 3, 4 right there. What did I do? Did I copy those wrong? Let's see. X squared minus 6x plus 13. Oh. Oh, thank you. That's the problem. There we go. Now do you see how... Now it should be obvious that both curves go through the point 3, comma 4. Right here, where my arrow is. 3, 4. Sure enough, at 3, 4, the average cost is equal to the low point. The average cost is equal to the marginal cost at that point. Okay. Store that one. On we go. Okay, the next section, number 18. Am I out of time?
No.
I've completely lost track of when this class starts and ends. Let's see, we began at 10 o'clock, is that correct? I get this, I wish all day we would either start on the hour or not, but, yeah. I thought, man, that went so fast. Well, it does anyway, but. All right, 18. You got another class, just go, John. Number 18, exercises 17 and 18. Find the amount S of advertising that maximizes the profit. Well, that seems overly simple, doesn't it? They give you the profit and they say, what will maximize it? That's like a part 1/2. I'm not quite sure why that fits there. So you just take the profit, take its derivative, set it equal to 0, and solve. I don't quite get what that's doing later in the assignment, but okay. There's not much to that. That's pretty simple stuff considering what we've got in our background now. I'll let it up there a second just so you can... Oh, you know, while you're doing that, I got to remind you, I forgot to show you something. This is strictly... Okay, this is a little... hang on a second. This is a little bit of studying advice, is what this is. Yeah, I'll get back. I'm going to try to do one more problem. When you're on the Survey of Calculus site, I hope you're not... What? I hope some of you are trying some of these links. Let me give you an example. You know, we've been talking yesterday. We spent 2 days talking about optimizing problems, right? If you look on here, do you see this section? There's only one objective: solve real-life problems. Did you look at this link here? Okay, let me just show you. This is me again linking to my online calculus course here. Let me just show you what this looks like and how there's lots more examples out there if you want to just look. So here's the lesson in the online class from a different book, but it's the same topic, optimization problems. Okay, you'll notice that right in the notes, I did sample 1, sample 2, example 2. So there's 2 problems done right there. Okay, then if you go to sample problems, there's 2 more problems of optimizing. Okay, so there's 2 of those. Then if I go back to the notes, there's a really cool online video on this right here. I just want to show you. I'm not going to show the whole thing, but they here's the graph of a function f. Okay. No sound on?
F of C is called the relative maximum or the local maximum. When x is
anyway, those are pretty cool too.
F has a relative maximum.
Don't forget that stuff's available, and
if F of C
you can control those.
All values of x not
You can come down here and stop it, start it again. If you
Now
want,
let's look at a different interval.
you can even go back to this paragraph, click on it, and it'll go.
Consider an interval
So you have,
along
it's
the
kind of,
function curve.
they're pretty cool.
The greatest value of the function in
I
that
just wanted to remind you that that stuff's available, okay? And, okay. Now back to where we were. Yeah. We were going to maybe do one more, and I think what we're going to do is number 34. You know, I should tell you what the assignment's going to be. It's kind of a weird assignment. It's in two pieces. 1 to 25 odds. And why would I? I guess I shouldn't pick 34, should I? For a sample problem, since that's not in the range. Okay, I just learned something. So what we'll do is, okay, so anyway, 1 to 25 odds, we've pretty much taken except that there's some word problems, but it's the same thing, maximum profit, minimum cost, minimum average cost, no difference. I was going to do an elasticity problem, but I guess I didn't assign those. So let's take a look at 37 through, there's only 3 problems there, 37, 39, 41. Let's just talk about those briefly. Okay, 37. The demand for a car wash is that's kind of interesting. What's different about that is that's not usually how demand is written. How is demand usually written? You want to just peek back on the previous page. Right by number 9, 10, 11, and 12. Isn't it usually solve for P? So I think that might have to be your first step, solving for P instead of for X like it is. Then, how do you change demand into revenue? Now you multiply by X. Now you got revenue. Okay. Now, the question is, can revenue be increased by lowering the price and thus attracting more customers? Use price elasticity of demand to determine your answer. Okay. Well, let's at least go through how to do that. Let's at least get it set up. Trying to get my okay, we probably need to remind ourselves of this. So I'm going to copy this part here. Yeah. We got to do P over X divided by dP dx. P over X divided by dP dx. And these are both at small p. And that's the elasticity of demand, eta. Okay, now given in the problem is x equals 600 minus 50p. We really need to solve that for p. So we will subtract 600 and divide by negative 50. Yeah, I'm going to just do it this way. What is that? 12? Yeah, I believe that's correct. So now I have a demand. So I'm really set to go. All I got to do now is what's let's calculate these two pieces. What's p over x? Well, that would be negative 1/50th plus 12 over x. And then, what is dp dx? I'm trying to find the pieces so we can do this division problem over here. So like, here's piece 1, now piece 2. Okay, derivative. And then, quotient rule. Denominator times derivative of numerator, that's goose egg, minus numerator times derivative of denominator over denominator squared. Because it was negative, this is what I'm taking the derivative of up here. That's a little confusing. I'm doing dp dx. This is just separate right now. Here's my p equation. So I'm taking...
So you always take the
I'm not quite getting your question. Say that again, please.
because you kind of did like half and half, didn't you? Why did you use the quotient rule if you did it out of the first one?
Oh, I see what you mean. Yeah, you're right. I did do half and half. I used one of each. That should have been just nothing there, right? Cool. It's a lot easier derivative then, isn't it? There we go. And now, finally, what is eta? It's this guy. Sorry, I did it again. Look at the right line. P divided by x, so that's negative 1/50th plus 12 over x, divided by this guy. Okay, let's see if I goofed there too. Anyway, what I'm supposed to be doing here is taking my p over x result and dividing it by my dp dx result. Here it is in raw form. Now, the type of division I did here is I thought I want to divide each of these things up on the top by negative 1/50th, right? So what happens when I divide negative 1/50th by negative 1/50th? 1. And then what happens when I get this divided by that? Well, I can see it's a negative, so I put a minus. And it's this guy times the reciprocal of this guy. And then I got 1 minus 600 over x. So there's my elasticity of demand. Now, one more thing I got to look up. The key number is when the elasticity of demand, the absolute value of it, equals 1. So when will that equal 1? I gotta think that through. Well, if we subtract 1 from both sides, we can't do that. It's 1 minus 600 over x equals 1, or 1 minus 600 over x equals negative 1. I think I need to look at these some more. So I think what we're going to do is I'm going to go back and change that assignment. Let's cross the second part off. There we go. So do 1 to 25 odds and then do that black rectangle. No.